Hi everybody, thanks for coming. So this is sort of not impromptu talk, but I kind of filled a void of a talk that wasn't able to be here. I guess the speaker wasn't able to be here, so I thank everybody for showing up. This is a talk I had originally submitted, and then they asked, they said during registration to me yesterday, they're like, well, we need speakers to fill a gap, and so I volunteered for this. So some of this was thrown together quickly. I had most of it already together, but thanks for showing up. So I'm going to be talking about the glitch. Hardware with hacking made easy, and yes, this phrase weird, and I accidentally put that in, and when I submitted the CFP, and I saw that after David posted it, but it kind of actually makes a little bit more sense to phrase it that way, even though that's not how you might think of it. So we'll talk about that. I'll talk about that later on, kind of where we're going with that. But I'm JP Dunning. My handle is Ronan, and if you don't know it, you're at DerbyCon. This is what I'm going to be talking about today. What's inside the case mostly. This is the glitch. It is very small. That is a quarter, and that is a 3D printed case for it. 3D printing, lots of fun. So what is the glitch? Why are you guys here? It's inspired by hardware security projects that I've seen in the past. A lot of stuff by Iron Geek and some stuff by Relic. Like I've seen their talks over the last couple of years about using these small embedded pieces of hardware to perform certain kinds of attacks. And I just got really, really interested about a year and a half ago. So I was like, well, let me just play around with it, and since then I've just taken off with it. There's some really cool things you can do that it's kind of a unique attack vector. I wanted to create hardware that was specifically for security hacking platform purposes. There's a lot of similar hardware platforms out there, but I kind of like, what would I want to use as a pen tester? What would I want? So I'm basing it pretty much on that. It's made Arduino compatible. People here use Arduino boards. It's a pretty common, it's a very, very popular platform for microcontrolling programming. So I wanted to base it on that because there's a lot of resources out there already available. No need to reinvent the wheel. Lots of people are using it already. Let's just go with that. So I can leverage existing hardware so that you can connect additional hardware to this to make it do other things. And the hardware was built for this platform. So again, there's tons of additional resources out there. I'll just keep the ball rolling. Make projects accessible to non-coders and engineers, and this is a big part of it. I recognize that not everybody out there either is a proficient programmer or considers himself a proficient programmer or does hardware stuff. I mean, if you haven't soldered versus other steps of actually building your own hardware, that can be a pretty steep hill to climb to actually get into doing this stuff. So I really wanted to make it a low entry level to mess around with this hardware. Make it easier so it's more, you're doing a project, you release it, and you can get to a much wider audience. So making it easier for the users. I fight for the users. So what does it do? It's a reprogrammable microcontroller development platform. It's a development platform first and foremost so that developers can create new projects. It's not limited to the ones that I'm currently doing. I just don't want to do every project out there. I want to have my interests and be able to expose the device and say this is cool stuff that it does. Take it and do your own stuff with it. Some of you, and then release the code and make it available to everybody. The projects I've been working on, I started out with this, got inspired through the keystroke injection stuff that Iron Geek had done, and so I wrote a lot of stuff with keystroke injection, keylogger, and Bluetooth. I'm a big Bluetooth fan. Embedding it in hardware was another thing. A lot of these are inspired by other people's projects. And RFID, I like wireless stuff, so RFID, NFC, reader emulator boards. So being able to use this platform to control those technologies or interact in that way with the computer. And you can build or port a lot of other projects. So this is a development board that is, again, compatible with this platform where tons of different boards are already you can develop for, and they kind of cross-compile. So you can get porting a project that's already existing out there to this new platform is very simple to do. So how am I making it easy for the users? As I mentioned before, programmers can program, the people who do hardware, solderers can solder, and the users can use it. I really wanted to make it very easy for the users because a lot of this community does not do hardware. There's another side to it. If you have like a local hackerspace, that's generally actually more hardware related. It's not necessarily security stuff. And in our field, there are not a lot of people that do even mess around with hardware as a hobby. It's not necessarily professionally, but just hobbyists. So really low entry level. Users don't have to be developers, and that's a kind of new concept for this. A lot of these Arduino platforms, they hand you source code and they say do your stuff with it. So you have to program it, you have to maybe create a new board, do new hardware. I don't want you to have to do that, so the users can be separated from the developers. and you don't have to write any code. I'm doing a suggested framework to make this easier for the users, so the developers don't have to follow it. A lot of stuff will be compatible right off the bat, but if they conform to the standards that I'm going to publish, it'll again make it a little bit easier on you guys. And the glitch hardware, another way to make it easier is I'm going to have a micro SD, it has a micro SD adapter on it and a dip switch, and these are for user interaction. So you're used to using a micro SD card, that's just a file system that you can mount. Interacting with that is super easy. And then a dip switch is easy interaction with the hardware. Developer side, talk about the developers and the users. The developers create their projects, you know, do whatever you want, be inspired. If you mess with this stuff, great. Good, you do that. Build it in the Arduino platform. Arduino platform is in C, so if you know C, it's really, really easy entry level if you're doing programming stuff. And then you're, you know, bringing in other people's hardware. Leverage all these existing libraries. I would imagine there's millions of people that mess with these Arduino devices. I might say that worldwide, it's a very popular project. For just home automation, just all kinds of Tinker Toys, not just security stuff. People do all kinds of things, especially at like Burning Man. Most of what you see there, Arduino-based. So there's libraries, software libraries, compatible hardware. It's just tons of it out there online from all these different resources. So the extra part that the developers normally have to do is they write their code and they say, here, you want to change it. Here's my code. Figure out how it works. And, you know, jump through all the code and figure out what lines do what, and you take all the time and reverse it because, of course, they don't comment anything because you're a developer. You know exactly what you did, why it's open source, so they can figure it out on their own. It's generally how we do things. I know I'm guilty of that, having put software out there. But if you go the extra mile to leverage the micro SD card so people can use it easily and start reading stuff off the micro SD card, it's a lot easier for somebody to create a framework for the users to interact with point and click wise. It puts the payload on the micro SD card, and you're good to go there. So it's a little bit extra work on the developer side because you're not used to having to do all this additional reading off a micro SD card. But in the end, as a user, it's much, much easier. The dip switch, you're going to be able to select different modules based on the dip switch. So you can have one module set up to do one thing and then a completely different one. You don't have to reprogram it every time. You have tons of these dip switches to just select, okay, I want to run this one. Oh, on the fly, I decided that this attack vector is actually better due to my circumstances. I'll change that and run it against the system or, you know, leverage whatever hardware I'm using. So again, developer side, the user side, I've kind of been beating this to death. Really easy to use. Everything's micro SD card. Select the dip switch, plug and play. So it should be very quick. Once you have the board set up, the initial setup, if you want to keep reusing it, it's going to be super easy to do. Modules. I mentioned modules, and this is a way. Think of this sort of as like you know how you use Metasploit. You're getting a configuration. You find whatever vulnerable device. In this case, your target hardware platform. You have a configuration file, which is like going up and setting up the IP addresses and stuff in Metasploit. You've got whatever you want it to target, the specific attack. I have in these module folders a help file, which is nice. And so the help file is just literally that. If somebody can actually make a module and say post it to their website and say I made this cool module, you can use it too. And so this makes it a lot easier to know what's going on if I say you should put a help file in there. Again, people that use the tools of this community can appreciate having help in a help file. And then the other thing, depending on what you're doing, is you can have a payload in there. So these are three, pretty simple files. This would be like the interpreter payload, again, referencing Metasploit. This would be what you want it to do in the end. I say it's optional because, like keystroke injection, you might have a payload, but something like if you're going to do RFID reading, you don't necessarily have a payload to upload. You're just, scanning something and dumping it to a log. So it's optional in that, however the people are going to be using this hacking hardware, they would specify whether you need that kind of stuff or not. This is the basic breakdown of the hardware. It's a very simple board. People that know hardware, this isn't much here. Processor is what makes it Arduino compatible. I've got the micro SD, the dip switch, a couple programmable lights that won't blink on default because you might want to be really covert with this, and a lot of the other ones have blinky lights, and when you're trying to be covert, blinky lights kind of show, like, oh crap, something's there, that's weird. These are programmable, so a lot of times you might want to program a red LED if you have an error in your code, which is very helpful to get hardware. Debugging hardware is a big pain. Using LEDs to debug is a great thing. Solderless pinouts. Again, no hardware soldering needed for this project. You'll be able to plug in with little adapter cables So it's pretty much plug and play. And then a USB interface. You're programming all this stuff up through USB, which is a big step forward in the hardware days, because normally you had to have this intermediary hardware thing that would actually upload firmware, and you had to get their IDE, and it was just this whole expensive and difficult thing of pinning out. So this is just plug it in through USB, upload the firmware, and then, you know, configure it however you want. So what are some of the stuff? I mentioned the projects that I've been working on, and, you know, what it will come with. So I've been doing keystroke injection. That's where I first got into this. And what is keystroke injection? Emulating a keyboard. Basically, when you plug it in, it says, your computer says, oh, thank you, you've connected a keyboard to my local device, not knowing that it's actually a very tiny little microcontroller that you're baking on. The benefits of that, it types quickly, it types accurately, it does not require a human. Why would this be a good thing in certain environments? A lot of them, don't allow USB flash drives. Certain, it's more secure networks, they restrict certain things. So plugging in a flash drive might be, say, you know, we don't want exfiltration through flash drives, so we won't let them in there. But keyboards generally not blocked, unless all USB is blocked. If you have a desktop, you kind of need a keyboard on there. So that's generally not restricted through policy. So keystroke injection is kind of neat, and you're leveraging local stuff, so you're not necessarily having to bring anything weird onto the system. It works against pretty much any computer that you can plug in a keyboard, and the firmware takes care of all the running payloads. So I mentioned the environment I hope that developers follow. I am following that when developing my projects. So I take care of all the hard stuff for you, including so if you want to run something, like some of these payloads, I take care of the opening the run key and opening up Notepad and typing it in and running the script and deleting the script. All that is done in my firmware. All you have to do is supply the payload in a configuration file, and you don't have to worry about what weird Windows key brings up a run terminal and Alt F4 that closes an application. You don't have to look all that stuff up. I'll take care of that. So you can target 3 different operating systems. I have these 4 things running in all 3 operating systems. I say, you know, depending on your configuration file, you can either tell it I want to run a command, or I want to run a script, and then you supply what kind of script. And really, this is only for when you're going to open up in the terminal. You have to know what to put in the front of it. So it's going to be a Python script that types in Python space in the script name. A binary file, I can copy over a binary file in hex and then convert it back into binary and run that on all 3 operating systems. And the one that I wrote called Red Button, and you should never ever use Red Button. But, you know, sometimes you just have to, you have an idea, you just have to implement it, and then you tell people don't use it. But I called it Red Button for a reason. Slightly tempting. So what it does is it moves the mouse around randomly. It starts the run. I mentioned Control R, GUI R opens the run terminal. It types in 2 random characters and waits a second, then hits enter. So whatever application pops up in the run, it'll run that. And then it will hop around, it'll right-click every once in a while, left-click every once in a while, drag stuff around, kill stuff. So it's a great thing if you want to break a kiosk, or like, yeah, I don't know how to get out of this kiosk. You just plug this in, you know, walk away and come back, and it'll either be crashed or you have access to the desktop. So I've run this against myself accidentally, and that's why I say don't do that. It did not take very long at all. I mean, stuff was just popping up left and right, and then all of a sudden nothing popped up because the screen didn't move because it froze. So I don't recommend that unless you're doing it somebody else. I wrote a scripting language. So one thing about this is, you know, it types out a batch file and you can do a command. But what if you want to interact with the interface on another level? Like, how do you type in F4? If you type in F4 in a file, I assume you're typing in F and then 4 instead of the function key. So I wrote a scripting language that takes care of all of that. It'll take in plain text. It's got 4 components to it, and I'll show you an example in a second. You got your plain text stuff, which will just be your normal typing. It's got parsed modifiers, some command keys. There's modifier keys like Control and Alt are special keys. And the rest of the keys, it's going to parse those, and then there's special commands that are interpreted by the glitch that aren't really key related, like the time delay. If you want to do a time delay, there's no keyboard, there's no keystroke for time delay. You can tell the system through my scripting language that you want to wait X number of seconds too, because a lot of times you want to say, open up the run terminal, type in Internet Explorer, give it the URL to your payload, wait for Internet Explorer to pop up. Then the payload says, do you want to save? And you go through the 7 tabs, and then you type in, it's a big pain sometimes, but once you get it set, it's awesome. Because you hit tab X number of times, and then you type it in your directory, and you save it, and then it'll go back and run it. You can do all that using this script. That's just an example, but that's something you have to wait for Internet Explorer to pop up, because you don't just do it all right away. So a friend of mine, because I don't do web development, wrote a really cool JavaScript interface that runs locally, because it's JavaScript, you don't have to host it on there. Because I wanted to be able to send it out with people. And so it's a JavaScript interface that runs just off your local host to generate this code for you. Because you'll see that's what it ends up looking like, which is cool, except for it's a little bit cumbersome to write all that out when all you wanted is the control, or the GUI R key. You had to type out, 20 characters. So what this does, it's a point-and-click interface to say, I would like, to add the GUI key. I'd like to add R. And it types it all out for you, and then you just copy it, paste it, so your script is done. It's way, way simple. I don't remember if I have it on here, otherwise I can demo it. But this is very simple. This is, I assume, the hello world for this kind of thing. Control or GUI R opens up the run. I wait a second for it to make sure that it's running. Types out Notepad. Waits a second. Types out hello world. And then kills the process. Yay! We all love Notepad. Why? Because we always migrate to Notepad. So, and that would be a separate attack. But this is a very, very simple, not necessarily security-related one. But it's the simplest thing I could think of that showed you the wait command. That's the number of milliseconds. Opening up Notepad, etc., etc. So this is, I mentioned red button, destroyed my laptop. So I thought that wasn't cool. So when I was developing it, I decided to add in a safe mode. So in the dip switch, you will select modules in binary format. So you have, up is 1 and down is 0, and you're going to be counting through. So everything down is safe mode, and I'm asking people that are developing to make that do nothing at all. It does not do anything against your system or against whatever hardware, because sometimes you have to upload new firmware, and if you don't have it in a safe mode, then it will attack your system unless you do this correctly. And I figured everybody could figure out what 0 was. 1 types out the help. So I mentioned that every module can have a help file. Again, very nice. It goes through all the modules recursively and just types out whatever help you supplied, which is very, very nice when you can't remember of all the dip switches, if you didn't write it down, which one should run what payload. And then the rest of them are, do whatever you want to do. Okay, that was keystroke injection. I'm going to work through some of my projects really quick. There's also a keylogging adapter. So these are separate. You basically upload new firmware for each one of these projects, and that's all you have to do as the end user. It's very easy to do. Connect the USB host adapter to the glitch. Then your man in the middle, you have a keyboard. You have the, we know how keyloggers work. But the difference between this and other keyloggers I've seen online is you have a micro SD card. A lot of them come with like 4 megabytes of built-in memory, and they cost $150. You're like, why 4 megabytes? Like, how? And then the 8 megabyte one costs $200. Like, really? What are you using? That's tiny. Why not just use a micro SD card? That's what this does. Micro SD card logs it to the micro SD card reader that's on the glitch. You can retrieve the log in a couple of different ways. You can recover the glitch and have it, pop out the micro SD card, read the dumped log. You could set it to actually inject back to you. So, you assume after a certain number of days or whatever you're using, nobody's been typing for 3 hours. The system's still running. Let me just call up a web browser that just has your forum on it. Let me just dump everything that I keylog to your forum and then go quiet again. And then do that every time that nobody's used the keylogger for an hour. That's just an example. I mean, you can do lots of other stuff. You guys can probably be more creative than that of, using the ability of keystroke injection to retrieve the data. Another one is you can use it through Bluetooth. You can get the data back, and I'll talk about that in just a second. And there's probably a lot of other ways using, combining these different technologies to leverage to exfiltrate data and control data. The other cool thing that I did is the keystrokes are logged in HittyScript format. So it's the same, like if they literally typed in Control R, and they waited a second, typed in Notepad, whatever, it's recorded in that exact same format. So you can inject the same thing that they did, which is kind of neat if you want to see what happened, or you're trying to follow their log. It's parsed a lot better than some of the other keyloggers. It's just bizarre. So it looks a little bit cumbersome, but you can really tell what's going on, or you can see what's going on because it'll replay it for you. Kind of nice. Moving on, we have lots of hardware here. Bluetooth. You can connect to the adapter through Bluetooth. As I said before, am a big fan of breaking Bluetooth. This time I'm actually using Bluetooth, so yay Bluetooth. You can interface the glitch through a serial connection, which is what most Bluetooth commands use anyway. So you can make a software, and I have not done this on my end yet, but that runs on Linux, Windows, OS X, whatever, that'll be able to command and control any project really through Bluetooth. So I'm giving the example of keylogger or keystroke injection, but in the end, any project anybody wanted to hack with, you could command and control it through Bluetooth or potentially through other adapters, Wi-Fi ones, or I imagine there's GSM adapters out there too, which would be really cool. So you can retrieve the key logs, or you can send command and control as an alternative through the dip switch. So that's nice. Instead of having to use the dip switch, which you're physically present for, you have to know ahead of time, you can launch it through the Bluetooth, which I'm going to do right now. So I mentioned before that I kind of stumbled into this the other day. My demo literally died 5 minutes ago. I ran from my hotel up the street down here, and like as soon as I was like, oh, it's cool, it's working, and so the demo I'm going to give tomorrow. I'm giving another talk tomorrow at 2. The demo is part of that talk, and it will be up and running, and you get to see how cool that was. But I'll give you a demo that's okay, not quite as cool. So I know. Thanks for that. Yeah. All right. So we'll give you a demo then. So it's plugged in. We have blinky light on the Bluetooth adapter. Cool. I am going to connect to the Bluetooth via my A900 phone over Bluetooth. Alright, I got the connection. And serial. I'm using RF-COM, which creates a serial connection over Bluetooth, and I'm using Minicom to control the serial connection. So I have no idea what payload I want to run. So let me... I'm controlling it over Bluetooth. Yeah, I didn't have it touching. I have a built-in delay. So this is typing out the help right now. It's reading in from each module. They type out hello world. Yeah, okay, module. So I typed all that out. I read in from every module folder. These are all ones that I had set up before. So it's like, that's kind of cool. So that's, that's very helpful if you're in the field and you're like, crap, I don't know what to do. You just open up any text editor and it'll type it out for you. And then, you delete it and you go away. Or if you're really super smart, you write it down on a piece of paper. But this is your backup plan. This is your, oh crap, I don't want to have to open the micro SD card, plug it into my laptop, read it, edit it, whatever. This just does it instantly on any computer that you happen upon. So let's run a different one. Because the cool demo died, but I can do a demo that makes me happy. Because I am up here, so I get to do what I want to do. That's right. Alright, I'm going to create another serial connection to it. Step away so we know that I'm not actually messing with anything physically. Alright. I think this is the right one that I saw. This should give you an example of how fast it would type. It can actually type faster than the computers can handle, so there's generally a buffer. So if you, now for a song. Ooh, ooh, you're no stranger to love. Never gonna give you up. So, do I want to save this? Yes, I do, but I don't need to save it on there because it's on here, so congratulations. I've somehow managed to basically rickroll in one way or another in like every talk I've given in the last 6 months. Don't thank me. Thank Rick Astley for just existing. So demo tomorrow going to be way cooler, but yeah, I'll tell you at the very end. I'll tell you something also that I think is funny. My talk tomorrow is at 2 o'clock. All right, our talk tomorrow. Excuse me. Where's Chris? There we go. Our talk tomorrow. Me and that guy back there. It's not all about me. Right now it's all about me, but not tomorrow. I can share the stage. Thank you. Okay, so that's cool. What else can you do? Embedding in hardware, building off other people's cool ideas. We want to embed stuff in hardware. Actually, let me check the time real quick. Cool. embedding in hardware, at the moment, it takes more effort than I would like. In the future, I'd like to make this an easier process, again, on the end user that doesn't do hardware. I'd like to somehow streamline this, but for now, I had to physically modify some of the hardware through simple soldering. So if you're capable of soldering and you don't need to know how the hardware works or anything, you can do what I'm about to show you pretty easily. I saw this, I know Dave Kennedy talked about this last year, and then there was some other articles I've seen online about doing this, but there were no clear instruction guides. So you're going to get a clear instruction guide about how to embed this into other hardware. So you have to find open space to put it. That's key. You may need to modify the case that it's inside of. You may need to modify the hardware that it's going to be leveraging. And you want to try to leave it functional. So whatever you're going to be embedding the glitch into, it'd be nice if they plug it in and it did what it's supposed to do. Because if it doesn't, they're not going to be happy very long. You're not going to get that chance to attack. And it's not as hard as it sounds. And the other thing is, you're looking at, would you rather see these, weird adapters, like this looks suspicious on sitting on your desk, so why not hide it in something that looks completely normal on a desk and leverage that hardware? So, computer mouse. How many people have this computer mouse at their work? That is the standard Dell computer mouse that's been out for the last 5 years. And I just happened to get it at a thrift store. I didn't do anything special. I literally went to the nearest thrift store, grabbed a couple mouse, and opened them up and just saw what I could do. So, open the mouse, see how much hardware is in there, or how much space is in there. There was a surprising amount of open space in the mouse that's actually, it's compared to other mice that you use on the desktop, it's actually pretty small and sleek shaped, and it's got a little curve in it. There was a lot of empty space. I opened up a bunch of mice that had weird connecting angles and stuff like that. The first one that I did that I gave to Johnny Long about a year ago, I just used a USB adapter that I had lying around that was like that big. So it was I fit it in this Microsoft mouse that was luckily giant. But since then it's gotten a little better. So open the thing up, whatever it happens to be. Look for space. Looks like there's plenty of space in there. It's a very simple board. It's, there's so much space because it's conforming to your hand. The technology can obviously be smaller. So what do I want to put in there? Let's see, I need to keep this usable, so how about I put a USB hub in there? That USB hub is about the size of a nickel. It came in a bigger case. I went through several USB hubs that I bought online and cracked open the cases to see how small I can get them, how easy they were to unsolder. This is a really crappy USB hub, which like some of the other hardware that the hackers that we end up leveraging, crappy can be awesome for us because we want to break things, and crappy makes them easier. As you can see, this I just opened it up. That hot glue was on there already. I haven't modified anything. They had to use hot glue to make it work. They're soldering. Normally when you open up a board, you see solder points are very uniform. If it's well manufactured, they should all get the same amount of heat, blah, blah, blah. This had just globs on some of them. One of them was barely connected. One of them did not work. But, I paid whatever. It was a Chinese one that just had it was a non-named brand, which again was kind of nice because all the name brand ones look nice and big and they have the big logo on there, whatever. So open that up. So I got my USB hub. I think I have a picture of it, but I took off all of those connectors. You can kind of see on there's 4 pins, so USB obviously has 4 pins. Unsoldered all of those. You can clip them, unsolder them. It wasn't that difficult. But then I need a connector to the glitch. And my prototypes at this point were using mini SD or mini USB. I'm using micro SD now, or micro USB now. But it's the same thing. The USB connector actually adds a lot of space. When you're doing small embedding hardware, an inch square is actually a pretty significant amount of space. So I didn't want to have to adapt it to this, regular USB size, because the hub was obviously a regular USB size. You can see the wires coming off. Those go to a regular USB female, which has to wrap around that. So when you're trying to think in the space constraints, you're like, wow, that ends up being a lot of unnecessary space, and I just need to connect these pins. So disconnect that, soldered it back on here, and okay, next step, so I can connect to the glitch. I pulled out the USB cable that you can kind of see there at the very top. That's the cable that goes from the mouse to the computer. A lot of mice and keyboards have this removable in case it gets pinched or something, or in the factory it's just easy to assemble it that way, which makes it really great for us because you don't have to unsolder anything here. Just pop it up. If you ever built your own desktop, you've done stuff like this. It's just pinouts that you're putting in the right side. Very easy to do. So I took that, cut it off, strip the wires a little bit. Then I have the USB ends. This is the same cable that was being used by the mouse that goes off the screen there. That's the cable. I put it out to the USB hub side. So that's the side that connects to the computer. I put the adapter there as one of the USB ports that's going to connect back into the mouse. So now, even without the glitch or anything, you have a hub between a mouse. So the mouse is going to work fine because it's just connected to a USB hub. So the USB hub functions in a way to let multiple USB devices connect in. So that's cool. So now I have to hide it in there because, you know, this is my the second one that I did. And I really didn't measure anything. I just kind of got excited and threw it all together. So in theory, you could, you know, measure it exactly and make it. Bending of cables actually came into it as a factor of how much, you know, the plastic coating would let you bend and solder points and whatever. So, you know, you can measure that ahead of time if you're going to actually be doing this better than I did. But it all fit in there. So it's like, sweet. I've upgraded the mouse to be awesome. So there's nothing to see here. Once I close the lid, everything is good. But I got bored because I had an extra port. I had 2 extra ports. One of them didn't work. An extra one that wasn't doing anything. So it was like, well, I should just add a micro SD to USB adapter in there for funsies so that I can use the glitch to automatically launch whatever is on the micro SD card that happens to be brought up and bring that with me. And it also still fit inside the USB mouse, which is right up here. It does take a little bit of pushing in, but I mean, you can see right there, it fits inside. And there's the screw that holds the mouse together, left that intact. I ended up clipping, I think I have the top right here. There's sometimes little legs that hold down from the top. I clipped 2 of them. I really didn't have to, but it made it easier. There are more that you could clip that had actually more space in there. So this took nothing. This took a pair of scissors. A pair of scissors and a soldering iron. And that's pretty much everything that I've done here. That's not really advanced techniques, I don't think. And it all fits back in there, screws together, and goes back together just fine. Works as a mouse just fine. Little red laser comes on. You move the mouse around, it works right away. When you plug it in for the first time, your Windows says, I'm installing new drivers. And that's what it tells you. I'm installing new drivers. And you go, cool, I plugged in a new mouse. It needs to install new drivers. And then it moves on. So if you have a card in the micro SD slot, it might try to mount that. But if you don't have a card, it just says, you know, if you dig deep down in, you see these are attached USB devices. But of course, we all do that every time we plug in any USB device ever, is we see how many of them are mounted. And the average user is going to do the exact same thing. Mount. So this basically ends up being a nice functional Dell mouse that, you know, depending on what you want to do, you could have the key injection. And one thing I want to mess with that I haven't yet is trying to detect when the mouse is being used, like tapping the power lines in some way or tapping the communication channels to see, okay, the mouse is being used now, I'm not going to do anything, versus the mouse hasn't been used for an hour, let me now run my payload. So that's something else you can do in addition with this kind of, you know, hardware modification. You can find out what's there. I'll probably continue to mess with these mice just because they're so readily available and popular that they're easy to find. So it might be if I have special stuff that I want to do with it, I'd be able to throw instructions up there. So I had this done, and I talked about this a little bit at Hope. I talked about my keystroke injection library there. But right before that, I was like, the night before, I was, you know, got this done. I was like, what else can I hide it in? I planned ahead for this mouse thing, and I'd seen other people do it. So I basically went around my house, and it's like, well, let me just look. So I opened everything. There's just streams of plastic and screws everywhere. I opened up a keyboard. That was cool. Older USB hub. It's hard to see in this, but in the top right corner. I didn't modify any of these because this was just an impulse. I was like, open it up, throw it in there, stick it in, like, sweet, it fit. That's great. Keyboards, as I mentioned before, you know, it'd be a lot easier. This, you'd probably have to do a little bit of unsoldering from the board and replacing of stuff, but totally doable, and it's going to see a USB hub connected to a USB hub connected to whatever. So in theory, for the USB hub, you would kill one of those ports, and the user says, oh, I plugged it in and the port didn't work. Obviously, that's a malicious thing. It's not stupid hardware. Hardware, dang it. External DVD drive. Desktop, there's a port inside your desktop that is USB connected, and a lot of times you can, you know, have the idea is that you have additional USB ports to the front or the back that you can connect to. Bam! That is a really easy one. There's no soldering involved in that at all. That's another little USB hub there, that black thing around that it's plugged into. So I just took one that was already existing because it's built to do that. You just go down to your local computer store, get normally it'll have the little strip on the back that it's meant to hang out outside, but put it in there and ship the desktop off and have fun. So obviously there's no hard drive in there, but I mentioned before you want to have something on there that doesn't look terribly suspicious. So it's a lot of additional space. But that's the hard drive that's in my laptop because it was cheaper to buy an external hard drive of the same capacity than it was to buy an internal hard drive. And if you haven't ever done that before, there's just a little adapter. It's the same exact hard drive, literally the same hardware with a little adapter, and it was like 15, 20 bucks cheaper to get the internal one. So that worked out well because then I just cracked this open, is able to stick the glitch in there, and then plug it in. Yeah. Yeah. Yeah, that's a stupid idea. Yeah. So it's funny because now I use that adapter as my, if I have to do forensic for somebody or just backup stuff, I use the one. So it actually turned out saving me a lot of money because it was cheaper to get the hard drive, and I now had a serial, a SATA connector for a USB. So I've used that at several points. Yes. Yeah, it's really tiny. I carry it around with it all the time in case I have to, get somebody else's. Because we all carry all this random gear around, and that's one of those things that end up being way smaller than the adapters I found online. So double, triple plus, because I got to use it for this presentation. So I like breaking things. Where can I get one? So I've talked about this project a lot. I've been dabbling around with it actually for over a year now, not knowing that in the end I would want this thing manufactured and made to make it easier on the end user so you don't have to build this stuff on your own. So I launched a Kickstarter project a little while ago. And how many of you have checked out the Kickstarter project? Nice, thank you everybody. It's going to close down on Wednesday, this coming Wednesday. So I would love people to help me try to promote it here as much as possible. I was going to originally try to find private funding for this project and looked out there and had started through a lot of proposals, and I really decided in the end it came down to I want to make something that the community wants to use. I want to make something that's going to, be useful. So if they don't think it's useful, I won't make it. So I decided to go the Kickstarter route. If you ever use Kickstarter, it's basically a microfunding website where you give, as much, and in this end, you're going to get the glitch back. But if it doesn't become successful, then you don't have to pay any money. If it does, then you get whatever is the end result. I have surpassed the goal. As of right now, I have enough funding, which is awesome. Those lines crossed out were things that I had. Oh, thank you. Thanks. I should be applauding you guys. I mean, it's you guys in the crowd that have helped make this possible. So those are the things that have actually sold out already. So that was really cool. So I added another thing. I basically put together a bundle, the second to the last one, to add the keylogger, the Bluetooth adapter, the case, all in one. So you just get all that shipped to you to be able to play around with. You can get one of them. It's up online. It's Kickstarter.com. It ends, as I said, October 3rd. I would really love if people slam Twitter to help me out to just get this going. I met my goal, but the idea is to get more capital so that I can make these boards afterwards. Because if it ends up being a couple hundred boards get printed and none of them ever get made, this is not going to be as useful of a platform that's going to be able to expand to other people. People aren't going to develop for it. So the more that I can get, the more likely that I can continue on with this project, continue to get them made and available to everybody. So that's up on Kickstarter now, and that's all I got. So thank you guys for coming. Thanks for showing up. I'll be at the Hackers for Charity booth most of the weekend. If you have questions about it, I'm using that as the pitch to draw you over there anyway. So if you have questions or want to check it out, I have all my hardware and stuff there, so we can have a lot of fun. But thanks again. Oh. And I've got cards so you can remember where it is. So if you want to come and grab one of these cards, this will take you to the Kickstarter page. Make it rain. Yeah, Skydog, you had a question? Well, I have enough funds to produce the ones that I'm going to get, and then depending on how everything